and welcome to today's video where we're going to be talking about an introduction to differentiation, which is a topic usually covered in A-level maths but is touched on in some GCSE maths courses. What is differentiation? Differentiation is a technique used to calculate the gradient or slope of a graph at different points. And when we talk about gradient and slope, we mean how steep something is. So for example, you might recognize road signs that look like this to show how steep the road is. So that's what a gradient is. It's just talking about how steep a line or a curve is. So we'll first briefly mention about straight line. So straight line graphs, the gradient is actually pretty easy to work out, which is something that's usually covered before differentiation. So for a straight line, the gradient is constant, so it's not complicated at all. You've got the y equals mx plus c, which is the general equation for a straight line, and you should know that the m in that equation represents the gradient, and in order to work out the gradient, all you're doing is the change in y over the change in x. But it gets more complicated when it comes to curved graphs, so curved line graphs. Just looking at this graph, you can tell that it's not going to have a constant gradient as you would in a straight line graph. So this is where differentiation comes in. So at each point that you can see here, each of these 3 points, the gradient of those points is basically equal to the tangent at that point. So if you're ever a bit confused on what you're doing when you're differentiating a function, what you're doing is finding the gradient of the tangent at that point. So what is the gradient function? The gradient function is a function that allows you to work out the gradient at each point. So the gradient function we'll come on to later about how to work it out, but just so you know, when you work out the gradient function, that gives you the ability to then substitute in the x value so you can find out the gradient at each point, any point of a graph. The gradient function is also known as the derivative. So in terms of notation, there's different ways of notating it, but the most common one that's used is here. So for the function, so if y is a function of x, or you could write it as y equals f of x, we write its gradient function as dy by dx. And you can also see it as differentiate with respect to x. It's important to know that even though that symbol looks like a fraction, it's not a fraction at all. So for example, the gradient function of x to the power of n is nx to the power of n minus 1. So what that means is if you've got a graph that has a function of y equals x to the power of n, if you were to differentiate that graph, you would get nx to the power of n minus 1, where n is just a number. You could also write that as f of x equals x to the power of n, and again, when you differentiate that, you get nx to the power of n minus 1. So that's all well and good, but obviously it makes most sense when we actually have examples to talk about. Say we've got a graph with the function y equals x cubed. And up here, I'm just going to remind you that for the function y equals x to the power of n, dy by dx is equal to nx to the power of n minus 1. So then you remember what we're doing. So if y equals x cubed, then dy by dx is equal to, so this n here is a 3, so 3x, and then this n minus 1 becomes 3 minus 1, which is 2. So you get 3x squared, and it's as simple as that. So what you've just done there is you've differentiated, you've given yourself basically a formula that you can substitute x into and find the gradient of that curve. So y equals x cubed. If you just substitute a value in, you can find the gradient at that point. So for example, if a question was phrased for the graph y equals x to the x cubed, and they asked you the gradient at x equals 2, all you do is substitute this 2 into this equation, because as we said, this equation is what helps us work out the gradient. So the gradient of x equals 2 for this graph would be 3 times 2 squared, which is 3 times 4, which is 12. Okay. Great. We can, so before we do a couple more examples, I'm just going to just list some other rules that you need to keep in mind for differentiation, which can help you. Although this is the main one, but I'm just gonna tell you guys. So for example, so these are all the functions, and this is how to differentiate said function. So for example, x to the power of n, we already know how to differentiate that. We move the n next to the x and then to the power of n minus 1. But what about if you've got kx? What happens then? Well, if you differentiate that, it actually just becomes k. If you want to know why, I can quickly note that down here, why that actually works. So kx, you can also see it as kx to the power of 1, right? Because x to the power of 1 is just x, which is why we never write anything to the power 1, because it's the same. But I'm just saying kx is the same as kx to the power of 1. And if you use this rule up here and move the 1 here, 1 times k is still k. And then x to the power of 1 minus 0 is just 0, so k x to the power of 0. And you should know that any number to the power of 0 is 1, so that becomes k1. And obviously k times 1 is just k, so that's why differentiating kx becomes k. What if you've got an equation that's just equal to k, where this is, by the way, where k is any number. So what if you've got an equation where it's just k? Well, that actually differentiates to 0. And if you think about it, it actually makes sense. So imagine you've got a graph, and the graph is y equals 5. So we're saying that k is equal to 5. Well, for a graph where y equals 5, and this is 5, it's just going to be a straight line. Sorry, I know it goes a bit topsy-turvy at the end, but it's a straight line. So obviously it does not have a gradient because it's a straight line, and that's why the gradient is 0. You could also explain it by pretending that there's an x to the power of 0 here, and it will still differentiate. You can do that in your own time. Okay, and the final rule to know is kx to the power of n differentiates into kn x to the power of n minus 1. So this table, if you keep this in mind, it means that you should be able to differentiate any equation that comes to you. But don't worry, we're going to go through some examples together, but you can always go back to this table to remind you. So here's some example questions. So let's do, we want to find dy by dx for each of these questions. So first we're going to do y equals x to the power of 8. And hopefully you remember the rule. So if y equals x to the power of 8, then dy by dx should equal 8x to the power of 7. And the rule I'm using there is the fact that x to the power of n differentiated goes to nx to the power of n minus 1. Why don't you try y equals 4x? By the way, feel free to pause the video and test yourself. So for y equals 4x, dy by dx is just equal to 4. And the rule that I'm using there is kx differentiated becomes k. Next question, let's try y equals 7. And hopefully you remember that would be a straight line graph, so the gradient would be 0. Okay, let's try some more questions. So y equals 2x squared. To differentiate it, we get 4x. And in case you're not sure how I did that, I used this rule to the power of n differentiates to knx to the power of n minus 1. So I took that 2 and I multiplied it with the other 2, and that's why I got 4x and then n minus 1. Obviously you pretend you take that 2 and then minus the 1, and then that's how you get 4x. Keep pausing the video to test yourself, guys. So next one, 11x minus 4. To differentiate that, we can use this rule here. That just becomes 11. And if you remember, a number alone, it doesn't differentiate into anything, like it differentiates into 0. So we can just leave it at that. Let's try this one. Y equals x squared minus 3x. To differentiate that, you get 2x minus 3. So again, I'm moving the 2 here. 2 minus 1 is 1, so it's basically the same as just writing 2x. And then 3x differentiates into 3. Okay? It's important to remember that the questions you'll be asked in exams aren't always going to be as straightforward as them giving you a function and then asking you to differentiate it. So the most common way that they might phrase a question that involves you to use differentiation might be just to find the gradient at a certain point, and that point might be x equals 4 for the graph, y equals 3x squared minus 2x plus 1. And at first you might be like, how on earth do I go about this? But basically what they're asking you to do is first differentiate it. So 3 times 2 is the first step, so 3 times 2 is 6, and then 2 minus 1 is 1, so it becomes 6x. 2x differentiates into 2, and plus 1 doesn't differentiate, so as in it differentiates into 0. So you've differentiated it. But they're asking you for the gradient at a specific point. So they might give you coordinates, or they might just tell you the x coordinate. Either way, all you're doing is getting the x value and substituting it, as I mentioned earlier, into the gradient function. So that's what you do. And that equals 6 times 4 minus 2, 22. And what that's telling you is the gradient for this graph at the point x equals 4 is 22. Okay, and that's all we have. So remember to practice, and if you get stuck, if you need help, we've got plenty of maths tutors here at JC Tuition to help you. Thank you for watching.